Welcome back to the London Futurist podcast. In the last few weeks, the pace of change in AI has been faster than ever before. The changes aren't just announcements of future capabilities, announcements that could have been viewed perhaps as hype. The changes are new versions of AI systems that are available for users around the world to experiment with directly, here and now. These systems are being released by multiple different companies and also by open source collaborations. And users of these systems are frequently expressing surprise. The systems are by no means perfect, but they regularly outperform previous expectations, sometimes in astonishing ways. In this episode, Calum, Chace, and I, David Wood, the co-hosts of this podcast series, will be discussing the wider implications of these new AI systems. I'll be asking Calum if he has changed any of his ideas about what he has called the two singularities, namely the economic singularity and the technological singularity, as covered in a number of books he has written. Calum has been a full-time writer and speaker on the subject of AI since 2012. Earlier in his life, he studied philosophy, politics, and economics at Oxford University and trained as a journalist at the BBC. He wrote a column in the Financial Times and nowadays writes regularly for Forbes magazine. In between, he has held a number of roles in business, including leading a media practice at KPMG. In the last few days, he has been taking a close look at GPT-4. Calum, is the media excitement about GPT-4 and its predecessor ChatGPT overblown, or are these systems signs of truly important disruptions?
I don't think the media excitement is overblown, no. The systems are very impressive. They are a significant advance on AIs that we've had before. In that sense, it's not overblown. And it's also not overblown in that it's high time that something happened in order to get people thinking about AI again. There was a big flurry of interest in AI when DeepMind's system AlphaGo beat the world's best Go player back in 2016. And then the excitement died down quite a bit. It's been rumbling along, but nowhere near at the fever pitch it was back then. And what's coming in the next years and decades, thanks to AI, is so important that it's a really good idea if people are thinking about it a lot. So, no, I don't think the media excitement is overdone. There is undoubtedly some exaggeration about what the things are capable of, and they are still limited, but they're impressive, and it's important that people are thinking about it.
Could you provide a short explanation of what's happening inside these new systems and how they compare with what we've had before?
Sure. Well, this is a really complicated subject, so David, do jump in, contribute when I forget things, which I'm sure I will. I think we need to go back at least as far as 2012, when, as many of our listeners will know, there was a big bang in AI when Jeff Hinton and some colleagues got an algorithm called backpropagation to work and introduced a type of AI called deep learning. Deep learning is essentially a rebranding of neural networks, which have been around since the beginning of the science of AI back in the 1950s. But it had never worked in the sense it had never made any money for anybody. Because the computers and the data we had weren't significant enough, what happened was Hinton and others started using GPUs, graphics processor units, which are extremely good at crunching a great deal of data very quickly. And that, plus the availability of very large data sets, made it possible for deep learning, this rebranded type of neural networks, to work for the first time, or the first time lucratively. What's less well known is that in 2017, there was arguably a second big bang in AI, because a paper published by some Google researchers called Attention is All You Need launched a new type of AI called transformers. This is a new type of deep learning, a new type of neural net. What transformers do is they predict the next token in a sequence. And a token can be a word or a part of a word, it can be a piece of code, or it can be some imagery. They estimate the probability of what a range of options might be as the next token in the sequence. They're trained on absolutely enormous data sets, and they're trained using a process called self-supervised learning. In a nutshell, and to oversimplify, what a transformer does is it looks through a body of text and it kind of puts its hand over a word and has a guess at what that word is going to be, given its context, given what's gone before. And by doing this billions of times, it trains itself to be extremely good at getting the right next token. It will then tweak the probabilities so that it doesn't just produce the same response, the same output every time, and it will have a certain amount of originality. So that's what transformers are, and that's something that, as I say, launched with the second big bang in AI in 2017.
And one of the features that makes them really special is the amount of data they can process, which doesn't need to be pre-prepared in the way that the data input to earlier deep learning systems needed to be annotated, usually by humans. So humans would say, this is a picture of a cat, this is a picture of a Dalmatian, this is a picture of somebody frowning, and so on. And that was time-consuming to generate all these labels.
Exactly. That's why it's called self-supervised learning as opposed to supervised learning, where a human has labeled all the data in advance.
Now, ChatGPT is by no means the first transformer. So what was different about ChatGPT compared to what was before it? And maybe you could also explain how GPT-4 differs again in its capabilities.
Sure. GPT-3, which unsurprisingly was the third in a series of these systems, was launched in May 2020. GPT stands for Generative Pre-trained Transformer. So as I say, it's a type of transformer AI. GPT-3 had the then enormous number of parameters, which is analogous to a synapse in a human brain, of 175 billion. Since then, there have been even bigger models. And the thing about GPT-3 was that it produced realistic text at scale, which models had not done before. But then, even more significant, what happened in November last year, November the 30th to be specific, was ChatGPT was released. And the significant thing about ChatGPT was that the public could play with it. As the prominent AI researcher Jan LeCun said, it wasn't the first or the best large language model, but it was the first that the public could play with. By December the 4th, so just a few days later, it had 1 million users, and by January, it had 100 million users. And as a lot of people pointed out, that was probably the fastest ever uptake of any tech application. Microsoft got very excited about this because Microsoft had developed a close relationship with the organization which released these GPTs. That organization is OpenAI, which was founded in 2015 by Elon Musk and by Sam Altman, who used to run Y Combinator. Microsoft had invested a couple of $1 billion in the company and has now invested another 10 billion and has developed a privileged relationship with OpenAI's output. Microsoft got very excited about this because it spotted a possible vulnerability in search, which obviously is dominated by Google. Microsoft's Bing engine, which a lot of people say isn't very much worse than Google search, is a very, very distant second place in terms of the usage and the revenue it generates. Microsoft thought that these chatbots, these souped up chatbots, could superpower search and enable Microsoft for the first time to get Bing to be a serious competitor with Google. That caused a great deal of interest. As it turned out, Microsoft's first attempt to do this was slightly embarrassing because its product, which became known as Sydney, gave some pretty unwholesome replies to early users. So Microsoft then limited the number of questions that you could ask it per issue and the timing of sessions. At the same time, Google introduced a large language model called Bard, and that stumbled as well. On its launch day, Google's system made a factual error, and Google's share price took a major hit that day.
These problems that the users found, the strange things that the chatbots were saying, In principle, they're meant to be weeded out by a process known as reinforcement learning by human feedback. That was one of the distinctive new features of ChatGPT, as I understand it, compared to the earlier generations. That as well as being trained by this enormous self-supervised mode, there was a subsequent human phase in which humans would respond whether they liked or disliked the various answers that were suggested by the bot. And this was used to tweak or to give a new alignment, if you like, to what the chatbot was saying. But obviously, there are holes in this alignment process.
That's right. It would be an impossible task for humans to do enough fine-tuning to these models to make sure that they never jump the guardrails in the jargon. But they don't go wrong all that often. Now, what happened most recently was on the 14th of March, OpenAI released GPT-4, the latest version. They have been secretive about the precise architecture, so we don't know how many parameters it has. But what we do know is that it processes more tokens at a time than its predecessors. So ChatGPT could process around 4,100 tokens at a time. GPT-4 can process 32,000 tokens at a time, an order of magnitude more. And that enables it to work with longer text than previous large language models. GPT-4 is also multimodal. It can analyze images as well as text. It can take information in as images. And it's been shown by early users to do really quite remarkable things. One of the most interesting things that it did in the launch demo was it created a functioning website from just a page of handwritten notes. It makes fewer mistakes than its predecessors. It scores better on exams. ChatGPT passed the bar exam, but in the bottom 10%. GPT-4 is passing in the top 10% on bar exams. Although, as people have pointed out, it's important to note that that doesn't tell us how good a lawyer it would be.
But it's still impressive.
It is very impressive. And it does seem that these systems are able to do some basic reasoning, which is a bit of a surprise because they are essentially pattern recognition devices. It wasn't until quite recently thought that that process would enable them to do reasoning, and it turns out that they can. So that is impressive and interesting.
Because reasoning involves some kind of abstraction, spotting something that goes beyond just the actual data. So when asked to multiply two numbers together, it can do that even if it's never seen that particular multiplication in its training data.
Yeah.
It's able to work out enough about numbers and multiplication that it can do at least some multiplications. And similarly for other so-called emergent features that these large language models unexpectedly display.
That's right. And you mentioned emergent features. There's an interesting phenomenon that as you scale these large language models up, they get to a certain point and then they seem to take off and become disproportionately more effective. And we still don't really know why that happens.
People say it's a bit like when the temperature of water is reduced. It gets colder and colder, but it remains liquid until it reaches 0 degrees centigrade, and the properties change remarkably. It becomes solid rather than liquid. In the same way, when sufficiently many parameters are fed in, or sufficient data, then features become possible which previously were rather poor. These new features perform well in these cases. So it's still to be understood how that worked. But enough about the theory. What about the practical implications for people's jobs? What have you seen in terms of jobs being changed by GPT-4?
Well, there's a lot of debate about this. Some people say that the claims that this is going to transform the nature of work are overdone, but it does look to me as if the nature of knowledge workers' daily life is going to change quite a bit. To give some examples of the kind of things that GPT-4 can do, it can give you a transcript of what was said in a meeting, and it can produce a summary of the most important statements. And that summary can be as long or as short as you like, and you can determine what counts as important. It can summarize a long email thread and draft an appropriate response. It can analyze tables of data in whatever form you have it, create Excel charts with whatever statistical graphs you prefer, and it can turn a Word document or even just a scribbled handwritten note into a PowerPoint presentation or a fully functioning website, as I mentioned before. And all of this it can do in seconds. And this is the big thing. Humans can do all these things, but it takes us a lot longer. What I've just described would be the daily work of an awful lot of people today. If a machine comes along and enables you to do that work 10 times faster, then what are the consequences of that going to be? So imagine that you have a department in a bank and you've got 10 analysts. And from one day to the next, an analyst can do 10 times as much work in the time. Now, at a sort of very high level, one of two things can happen. Either the analysts, all 10 of them, start producing 10 times as much valuable insights. Hopefully what they don't do is just produce 10 times as many reports, which everybody has to read and waste everybody's time. They can either produce 10 times as many valuable insights, or you can do the same amount of work and generate the same amount of insights with 1/10 of the people. So this isn't potentially decimation, which was taking out 1 of 10. This is 9 times that. Now, humans at work do an awful lot of things other than what they're specifically paid to do. And so the gearing isn't complete. But nevertheless, making all of knowledge workers much, much more efficient like this is going to have a big impact. Firstly, it should make the economy much more productive. We should have a pretty big leap in productivity over the next year or so as these products start to be used effectively. And it should have a bit of an impact on the labour market as well. It seems to me that the way it will pan out will be somewhere in the middle of the two alternatives I suggested. So to some degree, people will just be producing a great deal more useful insights. But also to a degree, organizations will become more efficient in the sense that they won't need so many people doing the work that they did before. I think it's still going to be quite a few years before machines automate enough jobs that there is lasting widespread unemployment. Whenever a job is automated, what's always happened in the past is that that has created efficiency, and efficiency creates wealth, wealth creates demand, so there's demand for more jobs. It does mean that people have to retrain, they have to find a new job, perhaps find a new industry, and that can be painful. In the past, there's been a lot of automation, there's been a lot of churn in the job market, but it hasn't created lasting widespread unemployment. At some point in the future, that probably will happen, and I wrote about this at length in my book, The Economic Singularity. I think it won't happen until the time when machines can do almost everything that we can do for money, and that's some time off. But what the introduction of large language models into the workplace is going to do with knowledge workers is I think it's going to really increase the amount of churn. I think a lot of people are going to find that there simply isn't room for them anymore because their colleagues can do the work 10 times faster, and they're going to have to retrain and find new work. It's a bit of a cliche now, but a lot of people say that an AI won't take your job. And these machines are not good enough to do a whole job. What they do is they accelerate humans at work. They don't do the work entirely themselves. So it's often said that an AI won't take your job yet, but another human who can work better with AI than you can, they may well take your job. And I do think that is something we're likely to see.
And isn't one complication here that it's not just one job that's being changed, not just one occupation? The same general methods of these large language models or other generative AIs is having an impact on large numbers of occupations at the same time. So it's not just your current occupation can't give you a job anymore, so you can move to your second favorite occupation or your third favorite. It may be that all of these are being challenged in the same way. So the amount of retraining or redefinition of how you see yourself and what you want to do in the world, that must be a larger thing. So it's more of what you call a great churn.
I think that's right. These machines are going to affect most kinds of knowledge work all at the same time. And they're also being introduced much more quickly than previous forms of automation. David, when you and I started work, there were secretaries in every office. Those secretaries got automated out of existence, broadly speaking, by Microsoft Office, software products like that. But it took quite a few years, partly because when computers first arrived and software apps like Word and Excel, or Lotus 123, which was an earlier one, first arrived, They were clunky, they didn't work very well, and it took people quite a long time to get used to them. GPT-4 arrives in fully working form right out of the box, and it won't take very long before many people know how to use it pretty well. So I think we've got a situation where a very, very large number of people are going to be affected by these systems, and they're going to be affected very quickly. The change is going to be very fast. I frankly don't think we're ready for this. I think there's going to be a bit of a shockwave running through the economy. Now, as I say, humans do a lot of things at work other than the specific task that they're supposed to do. So it might be that the effect isn't as big as I'm thinking it will be, but I do think it's going to be quite significant.
Part of the surprise, isn't it, is that some of the types of work these new systems can do were previously thought by many to be beyond the capabilities of any automation. People said, yes, some factory workers will have their jobs automated out of existence, but we creative types will be safe, people said to themselves, because these systems are incapable of thinking original new thoughts. They're incapable of creating poetry or riveting short stories or the like. But I believe you've experimented with some short stories, some poetry, and although these systems may not be the best poet or the best short story writer in the world, they're probably good enough to replace the work of many moderate writers and moderate artists.
Yes, I've been experimenting with these systems for a while. A few years ago, I published a book with some friends called Stories from 2045, which is a series of speculations about what life might be like in 2045 and whether we might have an economic singularity by then. And we had an AI produce some short stories for that book, and they were terrible, really, really bad. When ChatGPT came along, I repeated the exercise, and it produced very good short stories. Only a few hundred words, wasn't really able to do much more than that. You certainly couldn't write a book with it. And now with GPT-4, you can write quite decent length chapters of non-fiction books, as well as speculative fiction. So the progress is really rapid. It's very impressive. We'll be right back after a quick break.
The People in Performance podcast offers insights into the strategic competencies, behaviors, and results needed to increase the performance of employees and leaders. The show looks at all areas of the world of work, including attraction and recruitment, onboarding, training, and succession planning. Tune in to get a better handle on the stages of workforce planning you need to master in order to guarantee long-term success in a rapidly changing world of work. New episodes drop each week. Check out the latest People in Performance episodes on your podcast platform of choice. Follow us on socials and read the latest articles at pppod.com.
So we're going to see more books produced more quickly, more pictures, more articles produced more quickly with fewer people involved. What does all this lead you to think about timescales for the bigger changes ahead? You've said we're not yet at an economic singularity because there are still plenty of jobs that humans will be able to do. But have your views changed as to how far away in terms of time from that transformation?
It's funny, you spend years forecasting something that's going to happen, and then when it does happen, you're kind of shocked by it. I don't think that I've fundamentally changed my timeline for the economic singularity. I still think we've probably got a fair few years before machines can do everything that humans can do for money. I think the great churn is quite possibly upon us this year. I think we might start to see it at scale. Then, of course, the other singularity is the technological singularity, when somebody creates the first artificial general intelligence and AI with all the cognitive abilities of an adult human. I used to think that was probably several generations away. What I now think is that it seems as if human intelligence is actually less hard to replicate than we thought. The machines are advancing faster than we thought, but it's more a case of it seems that they are able to catch up with us quicker. So in my mind, I'm no longer sure that we will get an economic singularity because I think we might get the technological singularity first. Sam Altman, the CEO of OpenAI, is on record saying that he thinks AGI might arrive in a decade or so. He's in a better position than I am to judge. So I'd have to give that possibility at least a 25% chance of happening. in which case I think we probably won't get an economic singularity. I think we'll get AGI first.
And what will that mean in terms of jobs? We won't have jobs, but AGI will be smart enough to create lots of things that we all need.
Well, when we get to the point where machines can do all the jobs that humans could do for money, in theory, machines will be generating lots and lots of wealth. And if we're smart, we can distribute that wealth so that everybody is extremely well off. And it's a great liberating process because humans no longer have to be wage slaves. Many people really like their jobs, and many people feel that their jobs actually give their lives some meaning. But the majority of people aren't in that category. The majority of people do their jobs in order to put food on the table. Their jobs might be a reason to get up in the morning, they might give some structure to their lives, but they don't really generate a lot of meaning. If we could free humans from that subjection to jobs, that would be a good thing. But the challenge of how to distribute the income and indeed the wealth that the machines are producing is really serious. I think the key to it is abundance. I think the key is to get the cost of making all goods and services down very, very close to zero. If we can do that, then the people who own the machines and the people who are therefore earning most of the money don't have to be taxed in an onerous way to generate a really good standard of living for the rest of us. Because it isn't good enough to give everybody a universal basic income, because a basic income by definition is a very low income. And it's not good enough for our future world to be one where almost everybody's living in poverty. We all need to be flourishing. These things need to be thought about in some detail. If we get to AGI before we have an economic singularity, then we will face that issue, but we'll also face some much bigger issues about whether the superintelligence, which I think will follow the AGI fairly soon, whether its goals, whatever they are aligned with ours. So we will have some much bigger issues to deal with, and I'm sure we'll deal with that in other podcasts.
So there's one question as to whether these new systems have changed our estimation of the timescales for the singularities. But there's another question as to whether these releases have changed our probabilities for whether we have a positive singularity or a negative singularity. And there have been quite a few people saying it's a great shame that these new features have been rushed out apparently quickly and that people are generating misleading information by it. It's a sign that the creation of AI is already out of control. It's being done in a competitive rush, a race to the bottom. Apparently, some of the AI safety people in various companies are being sidelined. Their opinions aren't being respected anymore. And therefore, it's a sign that we are in more jeopardy, that we're not going to get a careful creation of AGI. We're going to get a rushed creation of AGI, and that makes it more likely to be a dangerous AGI. Are you sympathetic to that line of worry?
Oh, I certainly understand it. And there was a report that Microsoft fired quite a bunch of their AI alignment people in their rush to adopt these new systems. But I'm also sympathetic to the view that absent the public availability of systems like this, very, very few people were thinking about it. Everybody's worried about war in the Ukraine, perfectly reasonably, turmoil in India and all sorts of places. And it needs a shock to the system. It needs people to have their attention forcibly drawn towards these systems, because we need many, many more of us, not just the technically literate in Silicon Valley and elsewhere. We need many people to be thinking about these systems and what they can do. I'm also sympathetic to the idea that it's only by putting a system like GPT-4 out into the public that you really find out where it will go wrong and how it will go wrong. You can do as many tests as you like in the lab, but you don't get anywhere near a decent test of it. So I don't think personally that it was irresponsible to release ChatGPT and GPT-4. And overall, the idea of relinquishment, the idea that we say, okay, let's pump the brakes, let's slow down development of AI, I think is just unrealistic. Even if America, which is currently the source of most of these leading edge products, even if America said, okay, we're going to have a blanket ban, nobody's allowed to launch a new large language model and all the existing ones have to be withdrawn. Do we really believe that Russia would stop developing them? Do we really believe that North Korea would? Do we really believe that Britain would? I just think it's completely unrealistic to think we can stop these systems being developed. So it's probably better that they're developed out in the open or demonstrated out in the open. OpenAI, as I said, has not released as much information as previously about the architecture of GPT-4, and it's been accused of going from being OpenAI to being closed AI. Again, I'm sympathetic to what they've done, because if you think these systems could be misused by bad actors, then it's probably not a great idea to make their life easier for them. I don't think there are any easy ways to get this process right. It's going to be a bumpy ride. But making it obvious how impressive these systems have become is a big part of getting everybody to think about them.
Final question, not about AGI, but about what might come before AGI, a V5 perhaps of GPT or other releases. What do you think may happen in the remaining 9 months of this year?
I have no idea when GPT-5 will be released or even whether there will be one. I think what we will see is other tech giants coming out with their large language models, because none of them will want to be left behind. I think what that means is that the price of using them is going to be kept low. I think that they will fundamentally be a commodity. I think that's good, because it's right and proper that everybody should have the chance to play with them. It's a possibility that one of the tech giants, Microsoft, seems to be well positioned at the moment. It's produced a series of products called Copilot, which use the large language models right in their applications in Microsoft Office. It's possible that one of them could develop a moat around their services, a competitive defense around them, and could therefore extract some monopoly revenues. But I think it's unlikely. I think they're going to be plentiful and cheap. And many, many people are going to experiment with them, and I would absolutely encourage our listeners to experiment with them.
And that's part of the pace of innovation. It's not just that there are the large tech companies who are creating these things. There are unprecedented numbers of people experimenting with the tools and combining them in different ways, learning how to prompt them in different ways, learning how to integrate them into existing systems in different ways. And so the pace of progress is accelerated by the fact that more and more people can get their hands on it. So I'm sure we'll have plenty to talk about in future podcasts.
Indeed. The pace of change has never been so fast, and it will never again be so slow.
Well, we'll have to do lots more episodes quickly in that case. To our listeners, look out for more episodes. If you like this discussion, please give us a 5-star rating so that more people will be invited by algorithms to listen and join the conversation. Thanks, Calum.
Thanks, David.